Have you ever wondered what it takes to start something truly massive? I'm not talking about a car or even a truck. We're talking about an engine that can be as tall as a 4-story building, an absolute mechanical titan churning out over 100,000 horsepower. This isn't just an engine, it's a powerhouse, and waking it up is a masterclass in precision.
Right, so forget everything you think you know about starting an engine. There's no key, there's no simple on button. Firing up a beast like this is a whole ritual, a meticulous process where every single step is absolutely critical. It takes knowledge, care, and a whole lot of respect for the power you're about to unleash.
Now you might be picturing the main engine that pushes the ship across the ocean, but we're actually starting somewhere else. We're talking about the auxiliary engine. You could think of it as the ship's beating heart when it's in port. It's the power source that keeps what is essentially a floating city completely alive.
So yeah, this engine is the real unsung hero. It's what generates all the electricity for the crew's cabins, the navigation systems on the bridge, the galleys, literally everything. Without this auxiliary engine running, a massive container ship is just a cold, dark, silent hunk of steel.
Before an engineer even thinks about starting this thing, they go through a pre-start ritual. It's kind of like a pilot's pre-flight checklist, but for an engine the size of a house. And every single check is designed to protect both the machine and, more importantly, the people around it.
First things first, you gotta make sure the engine's lifeblood is good to go. That means checking the lubricating oil levels and then priming the system to force that oil through all the veins and arteries of the engine. At the same time, you open up the cooling water supply. You see, an engine this big can't run for even a few seconds without perfect lubrication and cooling.
Okay, now this next part is so important. It's all about getting rid of water. Engineers have to drain any tiny bit of moisture from the entire air system. So why is this such a big deal? Well, you can compress air, but you absolutely cannot compress water. If even a little bit of water gets trapped inside a cylinder, the results are, well, catastrophic.
And I'm not exaggerating. The forces inside these engines are just immense. A tiny, incompressible slug of water can literally bend a massive steel connecting rod or crack a cylinder head clean in two. This step is all about absolute, painstaking precision.
So, with the fluids handled, we move on to a series of checks that are purely about preventing a mechanical disaster. This is where human responsibility really comes into play.
And this quote from the procedure tells you everything you need to know about the stakes. What you're seeing is a turning bar. It's basically a giant lever that engineers use to manually turn the engine over for maintenance. The checklist is very, very clear. It must be removed before you even think about starting.
Just imagine for a second what would happen if that massive steel bar was left engaged when the engine roared to life. The power would shred it instantly, sending metal shrapnel flying and destroying the machinery. That's why there's a safety interlock. If that bar isn't put back in its proper storage spot, the starting system just won't work. Period.
And finally, the last couple of safety steps. All the alarms are reset, so you've got a clean slate to monitor the engine once it's running. And of course, the most important check, making sure every single person is a safe distance away from this incredibly powerful and incredibly loud piece of machinery.
All right, the pre-start ritual is done. The engine is safe, it's lubricated, it's cooled, all personnel are clear. It's finally time to begin the final sequence. It's time to wake the giant.
So all the checks are done? Do we just hit the button now? Well, not quite. There's one last, really clever safety procedure to do before we introduce any fuel.
It's called the blow-through. What the engineer does is open these little valves on top of each cylinder called indicator cocks. Then they use compressed air to slowly turn the engine a few times. It's like clearing the engine's lungs before it takes its first real breath, forcing out any water or oil that might have leaked into the cylinders.
Once the blow-through's finished and the cylinders are clear, all those indicator cocks are shut tight. Now, and only now, is the engine truly ready for ignition.
And here we go. The engineer hits the air starting valve, and a massive blast of compressed air forces the pistons into motion, acting like a colossal starter motor. As it spins, fuel is injected, and the engineer listens, really listens, for that distinct change in sound as the engine picks up. That's the moment combustion starts and it begins to run on its own power. The second that happens, the starting air is shut off. The giant is awake.
And just like that, the ship has power. This whole meticulous procedure, performed by skilled engineers in ports all over the world, is a small but absolutely vital link in the chain of global commerce. It's the sound that means a ship is ready to keep our world moving.
When you get right down to it, this process is so much more than just a technical checklist. It's this incredible dance between powerful, precise engineering and the focused, disciplined responsibility of the people who run these amazing machines every single day.
And that really makes you wonder, doesn't it? What other incredible, hidden procedures are humming along just out of sight, all working perfectly to keep our complex world running smoothly?